Hello all, welcome to my YouTube channel Learn Machine. Today we'll talk about the topic how what does relation signifies and how it can help a data scientist or a machine learning engineer to choose a model. It will cover the basic aspect of choosing a model. Suppose we have a situation where I want to know what my salary will be. Just think of it. Suppose now I have a person which is known as a salary guru, which is designed or is an expert in telling the salary based on some parameters. Now I asked the same question to that salary guru, what my salary will be. But the issue was, it started to think based on what aspect should I tell the salary to that guy? Is it based on his city where he lives? Or based on his experience, should I tell the salary? Or based on education, should I tell the salary? Or based on type of work which he does, should I tell the salary? So the salary guru asked me to refine my question. Okay. Again, I asked the same question. What will my salary be? But now I uh, be one more a bit more precise based on the experience. Tell me what my salary will be. So the salary guru started to think and process the information. But based on experience, experience is a numerical value. It can vary between 1 month, 2 month, 3 month, 4 month, 5 month, as well 15 month. So I can have multiple salaries based on the amount of experience I have. So again, I have to refine my question a bit more. What will my salary be based on 4 months of experience? Now I provided all the necessary information, that is the independent variable and the amount of independent variable to find the dependent variable. In this case, dependent variable is my salary and independent variable is my experience. And the amount of independent variable, that is 4 months, the salary guru told my salary will be $15. Interesting, isn't it? But think of a moment how that salary guru was able to do all these things. What made that salary guru able to give predictions based on some input? Now, salary guru told me I trained my brain, or I learned the relationship between or the connection between the salary and the experience, or it can be the connection between salary and city, or it can be connection between salary and education, or it can be connection between salary and type of work. So the knowledge of this connection between salary and experience made my salary guru able to explain the answer when I asked him a question what my salary will be based on 4 months of experience. Now let's get a deep dive into it. How what does this word connection signifies and how does it relate to the word relation? I hope till now we are able to understand the situation. How come a dependent variable, that is salary, is related to an independent variable experience, and if we know the connection between these two, I can predict the n number of salaries based on n number of experience. Now, for example, I will take the concept of one variable to for explainability of this solution. I know the connection between salary and experience. Now, this word connection is termed as a relationship. Here, the word or the concept of relationship comes into picture. When two or more variables are dependent on each other or dependent on each other, then we call them as they are connected or they are related to each other. For example, there can be multiple cases. What will my salary be if I am a graduate or have a 10 months of experience? So in this case, the salary is depending on two variables, that is the education and the amount of experience I have. Similarly, the other case can be what will my salary be if I have 10 months of experience. In this case, salary is dependent on a one variable which is only experience. But there can be one more case where my salary will can be dependent on the city which I live in, for example Delhi, the kind of education I have, for example graduation, and the amount of experience I have, for example 3 months. Now this is one aspect of relationship, that is the number of variables. There is one more aspect. What will be the change in my dependent variable if my independent variable is changed? For example, or if my one variable is changing, how it will impact the other variable. For example, if I have more experience, will I get a higher or a lower salary? This is one relation. Or I want to know what kind of a change will I observe. If I am in Bangalore with 1 month of experience, will my salary be low or high? So this is the relation which I have with salary and the other variables. Now, in short, relationship, if I want to quantify it or tell it as a mathematical equation, it has three components. One component will be how many number of variables I have. The second component will be in which direction these variables are related to. And third will be by how much the dependent variable is changing if I change the independent variable. We will have a deep dive in all of these three components in the later stages. In short, relationship is like a rule that tells us how two values are related or dependent on each other. Now, to summarize, relationship has three aspects, that is the number of variables, direction, and the quantification. Now, let's start with the number of variables. Number of variables can be of two categories. Either it can be two variable relationship or it can be more than two variable relationship. For example, in case of two variable relationship, we will be having one independent and one dependent variable. In our case, it will be independent will be experience and dependent is salary. But in case of more than two variable relationship, there can be three cases possible. It can be independents are more than one, but dependent is one. For example, independent are experience and city. User can choose any kind of experience and any city, and based on these two variables, I have to tell him what my salary will be. Or it can be independent is one, but dependents are more than one. For example, the type of work which I do, and based on that, I want to tell uh, what kind of a salary will I be having and what kind of an education will I be having. Suppose if I am a teacher, I want to tell ki, okay, if I am teaching someone at a school, my salary will range between $10, and the amount of and the kind of education I have will be graduations or bachelors in science or these things. And the third aspect will be where we have both independence as well as dependent more than one. It can be independence can be type of city, the experience, and based on that I have to tell me what kind of a salary will I get and the kind of education will I get. So in short, the number of variable is the first aspect of building a relationship. Now let's go to the second aspect, that is the direction. Direction. Direction means here the direction of relationship between those variables. Direction means if both the variables which we are focusing on are dependent on each other, then there can be two cases. Either they are directly related. When I say directly related, it means that if independent variable is decreasing, dependent variable will also decrease. If independent variable is increasing, independent variable will also increase. For example, if experience is increasing, salary will also increase. If experience is decreasing, salary will also decrease. The second case can be indirect relationships, in which if independent variable is decreasing, dependent variable will increase. It will behave opposite to the independent variable. If independent variable is increasing, dependent variable will decrease. For example, if I say the education, if I for no education won't be a good aspect here. If I say suppose city, if I am going in a lower tier of city, suppose tier 3 city. In that city there won't be much facility, so my salary will be low. So in case if my independent variable is a city, tier of city, tier 1 city which has all the facilities, then my salary will also be high. If the tiering of city is low, that is one number is low, the salary will be high. If tiering of city is too higher, then my salary will be lower. So as just for an interpretation at the moment. And then there can be independent relationships as well. In independent relationship, it can be like s- both the variables which we are focusing are not at all connected to each other. If I change one variable, it won't impact the other variable. For example, it can be the the company which I work. It can be ABC company, it can be BCD company, it can be XYZ company, and they have fixed categories of salary for the experience band in all the three companies. If the salary, if the experience range is between 1 month, salary will be $10. If it is 2 months, the salary will be $15. If it is 3 months, salary will be $20. So irrespective of the company I work with, the salary is not changing. So this is the case of independent relationship. Now the most important aspect is of relationship is how to quantify them, because without even quantifying them, it's of no use to build a relationship, because until and unless we quantify them or generate some mathematical equation out of it, it's all theoretical. Now quantification, what does this word quantification means? Quantification means for a unit change in the independent variable, how much will be the change in the dependent variable. For example, for a unit change in the employee's experience, how much will the change in its salary be earned? Now, suppose if I have a tabular data, I collected the historical trends between experience and salary and collected and generated a table. So if we have 1 month of experience, the salary is $0.5. If we have 1.5 months of experience, salary is $1. If we have 2 months of experience, the salary is $1.5, and similarly it goes on till n. Now for a unit change, unit means for two consecutive values. In our case, based on simplicity, I decided zero point 0.5 month as the units. So each experience value is getting incremented by zero point 0.5 months. Now, when I do a unit change between salary, between experience, that is 1.5 minus 1, that is zero point 0.5 months, I observe that my salary is also getting changed by same unit, that is $0.5. It's a not a realistic case, but for simplicity and understanding, it's a very simple rate of change I'm giving you at the moment. So if I change zero point 0.5 months, my salary will also get incremented by $0.5. Suppose now if I say my salary at the moment is for 2.5 months is $2. I want to know if my salary, how much will I get if I have 3 months of experience? Just increment the salary by $0.5, because this based on the historical trend or the values or the pattern which is observed from the data, I can say for a unit change in that months, I'm getting $0.5. How this calculation or quantification actually happens in reality is we use mathematics for complex data sets which have n number of independent variables and n number of dependent variables. It can be one dependent and 10 independent, it can be 100 independent and one dependent. We use mathematics which help us quantify this relationship. We'll get back to uh, a bit more detail what kind of a relationship which we have, but this is the whole fundamentals of relationship. To summarize, relationship, it is like a rule that tells us how two or more values are related or dependent on each other, and how much is the impact of changing one variable, generally in our case independent variable, have on the other variable that will be the dependent. For example, if I change the independent variable, how will it impact my dependent variable? If I change my salary experience, how much my salary will get changed? In short, Again, tying it back to the dummy equation which I created, how many number of variables, that is the number of variables, in which direction, that is the direction, either in posit directly proportional or indirectly proportional, and by how much. This quantification aspect is determined by using mathematics. So in short, this is the whole essence of the word relationship which we use in the machine learning. And once we get the idea of the term relationship, we can have a better approach as a data scientist or as a machine learning engineer in designing or choosing our models to begin with. Now let us see some default or some known relationship which exist in our mathematics. So there are different types of relationships. On a broader level, we can categorize them as linear relationships. When I say linear relationships, it means that the independent and dependent variable follow a straight line. Either it can be increasing. If independent is increasing, dependent is also increasing. That is a direct relationship. If and that the second diagram is a case of independent relationship. If you see, no matter how much x you change, your y value is getting constant. So in this case, the salary is independent of the company I worked with. Now there can be a decreasing case as well. If I'm decreasing my salary, if I'm decreasing my experience, my salary is also getting decreased. So there can be these three cases. Now, to summarize in mathematical term, by default we know that the equation of line for two variable is y equals to mx plus c, y equals to c, y equals to minus mx plus c, where my m is the negative slope, which tells that if one is increasing, the other is getting decreasing. This negative sign tells us. Now similarly, if we have more than two variables, the equation will remain the same, but the number of variables and its respective m1, m2, m3 will add on. We'll talk about this M and C components later in a bit more in some time. Now there can be one more case as well. Non-linear relationship. Non-linear relationship is a kind of a relationship which follows a curvature. It can be circular, it can be parabolic, it can be cubic, or it can be hyperbolic. For example, for simplicity, this is the quadratic equation. So when I say if independent and dependent variable are following a quadratic relation, this is what their graph will look like based on a general equation. Similarly, if I say the independent and dependent variable are following a cubic relationship, based on this general equation, their graph will look like this. Now we have some higher order relationships as well. When I say higher order, it means that their power is more than 3 or more than 3. For example, see this, x to the power 4, y square. So these are called as complex relations or higher order equations, which are very difficult to interpret or visualize in a two dimensions. Now you might be getting confused what these B, C, D and M1, M2, M3, M and M are. So these things are called as coefficients of independent variable. These coefficients are actually that quantification term which we talked earlier in the relationship. They quantify the impact of changing the independent variable on the dependent variable. So for example, if I change x, by how much y will change based on this m. So I just simply need to multiply that m with the respective x value and add c, and it will tell me how much will the y be. Now this m, c, etc. in terms of modeling are called as coefficients or in normal mathematics as well, but there can be n number of values. How to find the optimal values if we are given some data set which you just visualize experience and salary? We have algorithms which can be very simple, like linear regression, which you usually work with, linear regression, tree based models, SVMs, neural networks. All these, during their supervised learning or training process, what they do, they trying to find these MCA be etc values only, and that values or such values which tend to minimize the error between the predicted value and the actual values as low as possible. So how, in short, in summary, how do we find these values? We find these values using mathematics. But in case of our modeling aspect, we have the respective models or algorithm which work on the data and trying to find the values by themselves in such a way that we get the optimized curves, because there can be n number of lines which pass through between dependent, and it can be like this, it can be like this, it can be slightly tilted. So we need to find the best solution. Now there are other functions as well, or other relationships as well, which are complex relations or complex functions. For example, if you see, now they are in three domains: x-axis, y-axis, and z-axis. So in short, there are three variables. Out of three variables, we can find f depends on x and y. So it means that x and y are independent variable, but z is an dependent variable. Suppose, for example, salary is will be the z-axis. X-axis can be experience and y-axis can be education. So if we say z f x and f salary is a function of cos of x minus y, it can be either of these curvatures. So it's we are trying to visualize how complex the relationships can be. In such cases, our normal or classical or statistical machine learning models such as linear regression, tree based SVMs might not perform better. That's why we switch to more complex models which are designed to get trained on these kinds of complex curvatures, like neural networks. Within that neural network, we have dedicated design architectures for respective tasks. In short, let's put it all together. If we know about the concept of relationship, it can help us choose the model which I need to proceed with. Relationship is connection between the independent and dependent variable. Relationship will have three aspects, that is number of variables, direction, and the quantity. How to quantify a relationship? We just saw. We can do it by mathematics, which gives us a function which tells how dependent variable in terms of independent variable, like y equals to mx plus c. Y will be dependent and x will be independent, and these m and c are coefficients which we found during the training of our model. Now, once we know the relationship between the data, what we can do, we can visualize the relationship between variables dependent and independent. We can generate some graphs, scatter plots, or some line plots, so that we can visualize whether it is a linear relationship, it will be, then it will form a straight line. If it is a cube parabolic relation or quadratic relation, we just saw it will form a parabola. If it is a cubic relation, it will form a hyperbola type figure. So based on that, I can know that which model should I go with. If it is a linear relationship, I can just simply use linear regression. Why to go with neural networks or more complex? My task will be done by linear models as well. If it is a non-linear, we can go with tree-based SVMs or something. But if it's a complex relationship, we need to go with neural networks. So this is how we start our process of choosing a model based on the data. But right now I am covering very naive aspect, that is the relationship. Within that relationship, before even choosing a model, we have to look at other aspects as well. The 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 nature of data, that is, if it is a temporal data, if it is a textual data, if it is an image data, based on that we need to take a decision. I hope you guys like the lecture. And this will be a starting video, and we will be having subsequent videos as well where I'll cover the neural networks, implementation and the concept, as well statistics as well and mathematics as well. So please like, share and subscribe Learn Machine channel, and thank you.